So, section 8.4 is multiplying special cases, okay? And today we're going to find the square of a binomial, and we're going to find the product of a sum and a difference, okay? So, there are some special rules that you can use to simplify the square of a binomial or the product of a sum and difference. If I take a look at a plus b quantity squared, okay, if I take a look at a plus b quantity squared, we know that a plus b quantity squared is equal to a plus b times a plus b, right? If I use the FOIL method, okay, I'm going to have a, well, if I use the FOIL method, and we have first, outer, inner, last, then we have a times a, which is a squared. Then we have outer, a times b, which is ab, right? And then inner, we have b times a, which is ba. And then we have last, b times b, which is b squared. Now, are those the same thing? No. Yes, those are the same thing. So, if I have an AB plus an AB, that's going to give me 2AB. All right? So, if I square a sum, this is a formula that I'm going to use. A squared plus 2AB plus B squared. All right, so the square of binomial is the square of the first term plus twice the product of two terms plus of the two terms plus the square of the last term. So here, if I had the a plus b quantity squared, you have to know what the a and you have to know what the b is, and they have to be the same, okay? So, the a's have to be the same, and the b's have to be the same. So, we end up with a squared plus 2 times a times b plus b squared. If I have minus, then it's minus 2ab. Does everybody see that? So if I have plus here, then it's plus 2ab. Okay? If I have a minus here, then it's minus 2ab. Got it? So, problem 1 is squaring a binomial. We have to know what's the a and what's the b. So, for n minus 7 quantity squared, a is equal to n. And b is equal to 7. Okay? Now, so here's our a, here's our b, and now we're going to put it into the formula a squared plus 2ab. Nope, it's going to be minus 2ab. Good catch. Good catch. Minus 2ab plus b squared. Now we just substitute in our a and our b. So we have n squared minus 2 times a, which is n, times b, which is 7, plus b squared. So that's going to be 7 squared. So when I simplify it, I have n squared minus 14n plus 49. All right, so a is 2x, b is 9. The formula is a squared plus 2ab plus b squared, right? There's the formula. So we have 2x squared plus 2 times 2x, which is a, times b, which is 9, plus b squared, 9 squared, right? So remember, when you have a product raised to a power, that exponent gets applied to everything inside the parentheses. Don't forget what we've already learned, okay? So this is going to be 2 squared, which is 4, and then x squared. You see that? Got it? So, then we have 2 times 2 times 9. 2 times 2 is 4 times 9 is 36. X. And then we have 81. Got it? Problem 2 is applying squares of binomials. Here we have a square outdoor patio is surrounded by a brick walkway. We want to know what is the area of the walkway. So how would I find just this red part out here? What would my first step be?
You would have to find how many feet are the length of the building.
Well, my question is,
No.
what is the first step? The 2 steps together. So step 1 is to find the total area of the patio and the walkway. You find the whole thing, right? Then what am I going to do with this patio? Then I need the area of the patio. What am I going to do with those? Then you're going to subtract them. Step 3 is you're going to find the area of the walkway by subtracting. Very good. All right, so to find this length, we have this x plus this little bit up here, 4, and this little bit 4 over here. So this is going to be x plus 8. Okay? And then over here, for the width, we've got the x plus the 4 down here and the 4 up there. So this is also going to be x plus 8. Let's put it in parentheses. Okay? So, we want to find the total area of the patio and the walkway. So, we've got and then, once we find the area of the patio, we're going to subtract it, right? So, we've got minus the area of the patio. So to find the total area, we've got x plus 8 quantity squared, because that's x plus 8 times x plus 8, right? And we have for the patio, x times x, which is x squared. All right, good. So now we're going to put it into our formula. And on this binomial, a is equal to x, and b is equal to 8, right? So, we've got a squared, which is x squared, plus 2ab plus 2 times a times b, okay? Maybe I should put these in parentheses. Okay, 2ab plus b squared plus 8 squared. And then we have to put the rest of the equation on, minus x squared. So now we're going to simplify. So now we simplify, and we've got x squared plus, this is 2 times 8, that's 16x, plus 8 squared is 64, and then minus x squared. And then we combine like terms if we can, right? X squared minus x squared, what happens to those? They cancel out. So, our final answer then is 16x plus 64. And since this is area, this is going to be what? Square what? Very good. All right, we want to know, problem 3 is using mental math, but again, even though it says mental math, we're going to write down what we're thinking, okay? So, what is 39 squared? Now, we can't do 39 squared in our head, like Bryce can, but we can change it. We can change it to something that we can do in our head, right? So, to get 39, we can do 40 minus 1, right? 40 minus 1 is equal to 39, right?
Yes.
And then, so there's the 39 squared, same thing. So here, A minus B quantity squared. Does everybody see that? So this is A, and that's B. So there's A squared, 40 squared, minus 2 times A times B, plus B squared. And now we can do that in our head, right? So 40 squared is 1,600, right? Because that's 4 times 4, that's 16, and add 2 zeros. There it is right there. Then we have 2 times 40, which is 80. And of course, 1 times 1 is, everybody can do that in their head, I hope.
1 times 1 is 1.
Okay, 1. So now you can simplify that and get 1,521.
Wait, but isn't it?
With 85, okay, again, I can use my head, but we can change it to something that we can do, right? So how about 80, what? Plus 5. Yes. So we have 80 plus 5 quantity squared. Or if I wanted to change it to subtraction, what could that be? 90 minus 5 quantity squared. You see? And then we just, there's the A, there's the B, we just put it in our formula. So we have 80 squared plus 2 times AB, which is 80 times 5, plus B squared, which is 5 squared, plus 5 squared is 25. So when we add this together, what are we going to get? So there's your final answer, right? You can do the same thing over here with the subtraction. All right, so you can see both ways work. So you can do plus in the binomial, or you can do subtraction in the binomial. You got it? All right, so now we have the product of a sum and a difference. Okay, so the product of a sum and a difference of the same two terms also produces a pattern. So if I'm looking here, we have A plus B times A minus B. If I do FOIL, first, outer, inner, last, you'll see A times A is A squared. Then the outer, A times negative B is negative AB, right? Inner, B, positive B times positive A is positive BA, right, which is also the same thing as AB. And then a positive B times a negative B gives me a negative B squared. And of course, look at what happens to that. It cancels out because those are inverses of each other, correct? So our final answer here, A squared minus B squared. So if I have the sum of an AB in the binomial times the difference, the formula is A squared minus B squared. So if we have example down here, x plus 2 times x minus 2, this is going to give me x squared minus the 2 squared, 4. So problem 4 is finding the product of a sum and difference. And again, all you have to do is know what your A is and know what your B is. Okay? So for example A is equal to x, right? B is equal to 9. Now the formula that we're going to use is A squared minus B squared, because this is the product of a sum and a difference. So we have x squared minus 9 squared, which of course simplifies to x squared minus 81. So over here, we have our a is equal to 6, our b is equal to m squared. And we're going to put it into the formula, a squared minus b squared. So a squared is 6 squared minus b squared. So this is going to be minus m squared squared. Now this is a power raised to a power. We multiply the exponents. So we're going to get 36 minus m to the 4th. Got it?
Oh, I got it.
All right. So a is equal to 3c. B is equal to 4. So we have a squared minus b squared. So that's 9 squared, c squared, 9c squared. And then over here, minus 16. All right. So here you can use the rule for the product of a sum and a difference to calculate products using mental math also. And again, remember, even though it says mental math, we're going to write down what we're thinking, okay? So here is the example, 64 times 56. Well, 64 is 60 plus 4, and 56 is 60 minus 4. When you do this one, your A and B have to be the same. Your A's have to be the same, your B's have to be the same. And one has to be plus, and one has to be minus. Is everybody clear? So you've got, for the first one, when we simplify this, we're going to have 60 squared minus 4 squared. We don't even have a 2AB, right? Canceled out. So we get 3,600 minus 16, which is 3,584. So for 52 plus 48, there's my A and B. So we've got 50 squared minus 2 squared, which gives us 2,500 minus 4. And then you can do the rest.
This part.
You were